Greetings dear students and welcome back to a new lesson of grade 11 physics. Now in the previous video we mentioned that if we have one vector that is making an angle with the x-axis or with the y-axis, we're going to just simply analyze the components into x and y, okay? And if the angle is made with the y component, so cosine goes with the y component, but if the angle is made with the x-axis or the x component, then we're going to say that the cosine goes with the x component, okay? Now in this lesson we're going to add one more vector, okay? So it's okay if you have more than one vector when you are analyzing the components of a vector, okay? Now how can we do this? Let's say we have two vectors. This is 25. I'm going to call this d, okay, d1 displacement. And let's say I have another vector. This is equal to, let's say this is d2, and the angle of this is equal to 20. Okay guys? Now guys, solving this like this, analyzing these two components on the same coordinate can sometimes mess things up, okay? You might confuse them. So what do? I'm gonna do something else. I'm gonna separate these two vectors, okay? So I'm gonna say this is my first vector and this is my second vector. And if you have more than three vectors, do that too, okay? It's the same thing. So this is my first vector. This is my second vector, okay? This is 25 degrees and I call this d1. This is d2 and I call this d2. So this is 20. Now just simply do the analyzing of these components of these vectors. So this is going to be what? This is going to be dx1. This one here is going to be what? It's going to be dy1. This one here is going to be dx2. This one here is going to be dy2. You see, very simply, okay? You can do it on the same coordinate system, but you might confuse them, okay? Now just find the components of this one, of the first one, and then the second one. How can I do this? Guys, you have learned that, okay? So just simply, because we have the angle made with the x-axis, so I'm going to say dx1 is equal to what? It is equal to d1 multiplied by cosine theta. And for y, I'm going to say dy1 is equal to d1 multiplied by sine theta. Do that to the other one too. So I'm going to say what? I'm going to say dx2 is equal to d2 multiplied by cosine theta. And then dy2 is going to be what? Is going to be d2 multiplied by sine theta. Okay? It's the same method, guys, but we just have two vectors, okay? Now you're going to say, teacher, I have two vectors now. I have two x's and I have two y's. Don't worry about that. Just simply add them together. So dx, let's say dx total is equal to what? Is equal to dx1 plus dx2. And for the y, because I have two of them, I'm going to say dy total is equal to what? It is equal to dy1 plus dy2. That is how I find the resultant, or the addition of these two vectors. Just let me refresh this because I think it has stopped working. Now this is how you can find the components of a vector, okay? Just what we have been doing now, or the one that you have learned in the previous lesson. It is the same thing, but this time we're going to do that to two vectors, okay? Now from this on, what are we going to do? We're going to say find the resultant vector. So the resultant vector is equal to what? It is equal to dx total squared plus dy total squared, okay? And then find the resultant vector, okay? And to find the angle, I'm going to say theta is equal to tan inverse dy. It's always dy, so dy total divided by, if it's v, it's going to be vy, so dy total divided by dx total. okay? And then find the angle. That's it, okay? I mentioned, guys, in the previous video that if you have two like directions, for example, south of east, we're gonna take the second direction. So I'm gonna take east. If I have north of west, okay, I'm gonna take west. If I have east of north, I'm gonna take north. Careful, okay? So you always take the second direction when you have two directions, okay? Now let's solve a question, and before that, let's look at this here. Now we have north of east, you have north of east. Which one is mentioned the second time? So it's east. This one here we have south of west, so I have south of west. Which one is mentioned the second time? The angle goes with that direction, okay? Let's solve a question, okay? It says a hiker walks 25.5 kilometers from his base camp at 35 south of east, okay? So this is my direction. Let me draw this. So we have this. So we have south of east. So this is south and this is east, okay? My angle is going to be like this. Why east? Because east is mentioned the second time. And D1 is equal to what? It is equal to 25.5 kilometers. Okay, guys? Now, let's move on to the second one. It says, and the angle is equal to 35. Let's not forget that. So the angle is equal to 35. Okay, now, let's move on. It says he walks 41 kilometers in a direction of 65 north of east. Okay? Let's draw the second one. You can draw it on here on the same coordinate system. It's up to you, but I prefer this way, okay? So this is going to be, it said north of east. So north of east, okay? So this is north and this is east. So this is going to be my angle, okay? This is going to be my vector, and the angle is made with the east or with the x-axis, okay? Now D2 is going to be 41 kilometers, okay? So this is my first vector, this is my second vector. Now, guys, what do we need to find? Let's read the question again. So it says determine the magnitude and the direction of his resultant displacement. So I need to find theta and I need to find displacement 2. Let's go. Now, remember, what did we say? We said the vector is going to be analyzed into two components. So this is going to be what? This is going to be dx1 and this is going to be dy1. Okay, this one, same thing. This is going to be dx1. This is going to be dy2. Sorry, this is 2. Okay, dx2 and dy2. Okay, now let's just calculate them very easily. It's very simple, guys. Okay, now we have dx1, which is equal to d1 multiplied by cosine theta. Teacher, why did you use theta? Why did you use cosine theta? Because the angle is made with the x-axis, guys. This is x-axis. If it was made with the y-axis, I would say dx1 is equal to sine theta. Please be careful. So this is going to be what? This is going to be d, which is equal to 25.5 multiplied by cosine 35. Okay, cosine 35. Let me see the result. So the result is equal to 21 kilometers. You know what? Just let's calculate it. Okay, so we have 25.5 times cosine 35. So we have 20.8. So this is going to be dx1 is equal to 20.8. But I'm going to call it 21 kilometer. That is my dx1. Let's find dy1. So dy1 is going to be what? Is going to be d1 multiplied by sine theta. Now, I know you are smart. You know why did I use sine theta? Why I didn't use the cosine? So dy1 is equal to what? It is equal to 25.5 times sine of 35. Okay, now let's calculate that. You have 25.5 multiplied by what? Multiplied by sine 35. Okay, now I just want to mention something else here, which is, guys, look at the y. dy1 is going downwards. Okay, I don't want to say it, but please, before I say it, think about it. Okay, am I missing something here? Yes, of course. I should add a negative to this angle. Okay, why? Because this y, guys, is going downwards. It's going to south. South is what? It is negative, so careful. Okay, so my dy1 is equal to what? It is equal to negative 14.6, but I'm gonna call it negative 15 kilometers. Okay, please pay attention to the direction. Okay, pay attention to the direction, as if, of course, it's going to change the result. Okay, because we are adding the vectors. Okay, so you have to be careful with the direction. This one is going up, so it's going to be positive. It's going to the right, so it's going to be positive. So no need to worry. Okay, now we have what? We have dx2, which is equal to d2 multiplied by cosine theta. Why did I use cosine? Again, because the angle is made with the x-axis. Well done. Now this is going to be what? 41 times cosine 65. Okay, let's calculate this. So we have 41 multiplied by cosine 65. It is equal to 17.3. So 17.3 kilometers. Okay, that is my dx2. Then we have dy2, which is equal to d2 multiplied by sine theta. Why sine? Because the angle is made with the x-axis. Now d2 is equal to what? 41 times sine 65. Okay, so 41 multiplied by sine 65. I don't need to add negative because the angle, the vector is going up. So the result is equal to 37.1 kilometer. Okay, that's it. Let me add the vectors now. Okay, let me add the vectors now. Okay, so we have what? We have, let me use a different color. Okay, so for dx total, so dx total, this is equal to what? This is equal to dx1. Okay, so I have 21 plus dx2. Okay, dx2 is equal to 17.3. So 17.3. So we have 37.1. Oh, sorry. 17.3 plus 21. So I have 38.3 kilometers. Okay, this is what? This is dx total. Now dy total is equal to what? I have negative 15, careful. So negative 15 plus 37.1. Okay, so negative 15 plus 37.1. The result is equal to 22.1 kilometer. Okay, so this is the result. Okay, now what do I need to do now? I need to find the resultant vector. Okay, so the resultant vector, guys, is equal to what? It is equal to dx squared plus dy squared. Of course, total. So let me write total. So total. Okay, so this is equal to what? Square root of what? Square root of 38 squared plus 22.1 squared. Okay, so let's calculate this. We have 38.3 squared plus 22.1 squared. Okay, We have 44.2 kilometers. So the resultant vector is equal to 44.2 kilometers. Okay, this is the resultant vector. Am I finished? Unfortunately, no. Okay, let's find the tan inverse, guys. Let's find the tan inverse. Okay, so sorry, let's use the tan inverse to find the angle. So theta is equal to tan inverse of what? Of dy total divided by what? By dx total. Okay, now so theta is equal to tan inverse of what? Of, let me check. So dx is equal to 38, dy is equal to 22.1. So 22.1 divided by what? By 38.3. Okay, let's calculate this, and we have an angle of 30. Okay, let's make sure. So tan inverse of 22.1 divided by 38.3. Okay, let's make sure. Yeah, we have 29.9. Okay, so 29.9. This is question 1. Okay, please, if you didn't understand this question, solve it again and again. Watch the video, okay, again and again, until you learn how to solve this question very easily. Okay, you might want to try new questions, but not until you get this one. Okay, please try to understand every detail in this question. Okay, don't leave anything out. Okay, now we have question 1. Let me delete this. Most of these questions, by the way, guys, they have the same idea. Okay, so I'm not going to solve every one of them. I'm going to leave some for you, but they basically have the same idea. Okay, so it says a football player runs directly down the field. I have drawn this for you. So it says a football player runs directly down the field for 35 meters before turning to the right at an angle of 25. So he's moving like this, so it's going to be d1, which is equal to 35 meters. Then suddenly he goes to the right at an angle of 25. Okay, so he goes here and he makes an angle. Let me erase that. Okay, he goes here and he makes an angle of 25 from his original direction and running an additional 15 meters. So d2 is equal to 15 meter. Before getting tackled, okay, what is the magnitude and the direction of the runner's total displacement? Okay, so let me draw this for you. Okay, we have this, guys. We have two vectors. This is the first one. As I told you, always draw two vectors and always draw two coordinate systems. Okay, so first he moves like this. This is d1, which is equal to 35 meters, and then he goes like this and he makes an angle of 25 and running about 15 meters. So this is going to be my d2. Okay, let me check. So if we don't make any mistakes, so 15 meters and 25. Okay, it says find the theta. So theta is equal to what? And the displacement too. Okay, now guys, look at the first one. Look at the first vector. Is it logical for me to analyze it into two components? No, because it's already on x component. So y is equal to 0. Careful. Delta y is equal to 0. Okay, so d1, okay, d1 or dx1, sorry, dx1 is equal to 35 meters because it's already on the x-axis. But dy1 is equal to 0 meters. Careful. Why? Because it's only moving on a straight line. It's only moving on x-axis. Careful. It's not going to the y. It's not going to, or it doesn't have any what we call angle. Okay, it's not having an angle. it's just moving straight on the x-axis. So this is my dx and this is my dy. For this one, of course, I'm going to analyze this into two components. This is going to be dx2, and this one is going to be what? This one is going to be dy2. Okay, now let's calculate this. Of course, we need to calculate this. So we have dx2, which is equal to d2 multiplied by what? Multiplied by cosine theta. Okay, and then dy2 is equal to what? It is equal to d2 multiplied by sine theta. Okay, this is equal to what? This is equal to 15 meters multiply, I don't have to write the meter, so 15 times cosine of 25, and this is equal to what? This is equal to 15 times sine 25. Okay, let me calculate both of these. So 15 multiplied by cosine 25, so this is equal to 14 meters. What about this one? So 15 multiplied by sine 25, I have 6.33. Did I miss something? Yes, don't forget to add a negative to this one. Okay, so 6.33 meters, but negative. Don't forget. Why? Because this y is going downwards. Okay, don't forget this, please. Do not forget this. Now, let's calculate dx total. So dx total is equal to, I'm just going to call it dxt. So dx total is going to be what? dx1 plus dx2. So it's 35 plus 14. Okay, so the result is going to be what? It's going to be 49 meters. Okay, dy total is going to be dy1, so 0, plus negative 6.33. Okay, so of course this is going to be negative 6.33 meters. Okay, as because I have only d1d, okay, 1y. Okay, now let's calculate the resultant vector. Let's write this in a different color. So the resultant vector is equal to what? It is equal to y squared, of course, 49, this one, x squared, sorry, plus, of course, the total one. Okay, so negative 6.33 squared. Let's calculate this. So we have 49 squared plus 6. That's going to be positive because it's squared, so 6.33 squared. Okay, so we have 49.4 meters. So the resultant vector is equal to 49.4 meters. Okay, let's find the the theta. Okay, so theta is equal to what? Tan inverse of dy, of course, total divided by dx total. Okay, so theta is equal to what? It is equal to tan inverse of what? Of dy, which is equal to negative 6.3. So negative 6.33 divided by dx total, which is equal to 49. Okay, now let's calculate this. So we have tan inverse of what? Of negative 6.33 divided by 49. Let's calculate this. The angle is equal to, theta is equal to negative 7.3 degrees. Okay, you see, it's really important to know the direction, otherwise your whole calculation is gonna be wrong. Okay, so be careful. I have this question, guys. It's the same, but I'm just gonna solve it. So we have d1, let's separate them, and I have d2. It says a plane travels 2.5 kilometers at an angle of 35, okay, to the ground, then changes the direction and travels 5.2 kilometers. Okay, so the first vector is like this. It says to the ground, careful. Remember, what did I say? I said if it says to the ground, it means the angle is made with the x-axis. So it's equal to 35. And the displacement d1 is equal to 2.5 kilometers. Okay? Then changes direction and travels 5.2 kilometers at an angle of 22.22 to the ground. Okay? This time it changes the direction. Okay? So this is going to be my second vector, but this time the angle is equal to 22, and d2 is equal to what? It is equal to 5.2 kilometer. Okay? Okay guys, now why did I put it with the x-axis? Because again it says to the ground. Now what is the magnitude? So d is equal to what? And the direction theta is equal to what? Let me just analyze this into two components. So this is x component, so it's going to be dx2, and this one is going to be dy2. This one here is going to be what? It's going to be dx1, and this one here is going to be dy2. Okay, so let's just calculate that. For dy1, by the way, this is wrong. This shouldn't be 22, it should be 35. Okay, now let's calculate this. We have what? We have dx1, let me use black. So we have dx1, which is equal to d1 multiplied by cosine theta. dx1 is equal to what? It is equal to 2.5 multiplied by cosine 35. Okay, so let's calculate this. We have 2.5 multiplied by cosine 35. So dx1 is equal to 2 kilometers. Okay, this is my dx1. Let's find dy1. So dy1 is equal to d1 multiplied by sine theta. Okay, so dy1 is equal to 2.5 multiplied by sine 35. Okay, let's calculate this. So you have 2.5 multiplied by sine 35. We have what? The result is equal to 1.4 kilometers. Okay, what about the second one? This is the first one. What about this one? So dx1 again is equal to, but sorry, not dx1, dx2 this time, is equal to d2 multiplied by cosine theta. dx2 is equal to what? It is equal to 5.2 multiplied by cosine 22. Okay, then let's calculate this. 5.2 multiplied by cosine 22. We have 4.82. So dx2 is equal to 4.8 kilometers. Okay, let's find dy. So dy 2 is equal to d2 multiplied by sine theta. dy2 is equal to 5.2 multiplied by sine 22. Let's calculate this. So you have sine, so you have 5.2 multiplied by sine 22. So dy2 is equal to 1.94 kilometers. Okay, now guys, this is how we find the x component and the y component when we have two vectors. Okay, even if you have one vector. But when I finished, don't be so happy. Let's find the resultant vector. Okay, so the resultant vector is equal to what? It is equal to dx total plus dy total squared. But I don't have them. Let's find them first. Okay, so dx total is equal to dx1 2 plus dx2 plus 4.8. 4.8, so this is equal to 6.8 kilometers. Okay, dy total 1.4 plus 1.94. Let me add this. So 1.4 plus 1.94, we have 3.34. So we have 3.34 kilometers. Okay, now let's add it in the resultant, or let's find the resultant vector with it. So we have dx total, so 6.8 squared plus 3.34 squared. Okay, let's find the resultant. 6.8 squared plus 3.34 squared. We have 7.57, so we have 7.57 kilometers. Okay, this is the resultant vector. Let's find the angle. Okay, so theta is equal to tan inverse of what? Of dy total divided by dx total. Okay, so this is going to be what? Tan inverse of dy total is equal to 3.34 kilometers divided by 6.8 kilometers. Let's calculate that. So we have tan inverse of 3.34 divided by 6.8. Okay, now let's find this. So theta is equal to 26.15 degrees. Okay guys, so you have question 3. A tiger trainer in a zoo runs 8 meters north, turns 35 degrees east of north, and runs 3.5 meters. Then, after waiting for the tiger to come near, the trainer turns due east and runs 5 meters to get the tiger in the cage. What is the trainer's total displacement? So we only need displacement this time. Like every time, because this time we have 3 vectors, so always try to separate them, don't add them in one coordinate system. So first we have what? It says a trainer in a zoo goes 8 meters north. Okay, so we have north, and this zookeeper is going, or zoo trainer is going 8 meters north. Okay, so you already see that I don't have x component, I only have vector component. So that is my first vector. The second one, guys, the second one, it says turns 35 degrees east of north. Okay, so this is going to be this is east and this is north. It says east of north. What is the second direction that is mentioned? Of course it's north, so it's going to be 35 degrees, and then d2, let's call that d2, is equal to 3.5 meters. This one is d1 and is equal to 8 meters. And then the last one, it says, then after waiting, what is it for the tiger? The trainer runs due east. Okay, look at here, please. So you have this, he runs east again, and then the d3 is equal to 5 meters. How can I calculate this, guys? It's very, very easy. So for the first one, I have no x, so dx is equal to 0, dy1, so dx1 is equal to 8 meters. Okay, I have no x component, so I don't have to add that. For this one, guys, remember, because the angle is made with north, okay, so dx2 is gonna be what? Is gonna be sine theta. Okay, it's going to be 3.5 multiplied by sine theta. Why? Remember, because this vector is going to be added into 2 components, analyzed into 2 components, dx 2 and then dy2, like this, guys. Okay, now I know that the angle is made with the north or the y component, so cosine goes with the y component, careful. Okay, so let's multiply this. 3.5 multiplied by sine theta, which is equal to, this is equal to 35. Okay, multiplied by sine 35, we have what? We have 2 meters. So this is going to be equal to what? 2 meters. Let's calculate dy2. dy2 is equal to 3.5 multiplied by cosine 35. Why cosine 35? Because the angle is made with the y-axis, careful. So 3.5 multiplied by cosine 35. I have what? I have 2.86 meters. That is my dy for this one. For the third one, guys, here I don't have dy. Okay, so dy3 is equal to 0. dx3 is equal to 5 meters. Okay, now very easily, we don't have to find the angle, guys. If you want to find it, it's okay, but we only need d. The displacement is equal to it, so I need to have what? dxt, I'm gonna call it, which is dx total, is gonna be what? Is gonna be all the x's that you have added together. Here I don't have x. Here x is equal to 2 meters, so 2 plus. Here I have only one x, so 5. 2 plus 5, then this is equal to 7 meters. What about d total? dy total. Here I have 8, so dy total is equal to 8 meters plus. Here I have dy2, so it's equal to 2.86, so this is equal to 10.86 meters. That is my dx total and dy total. And to find the resultant vector, guys, we're going to say what? Resultant vector is equal to what? Square root of dy plus dx. So dx or dx plus dy. So 7 squared plus 10.86 squared. Okay, so this is equal to what? Let's calculate this. We have 7 squared plus 10.86 squared. We have 12.9 or 13 meters. Okay, guys, so we have question 4. It says an airplane flying parallel to the ground and that goes to consecutive displacement. So we have 2 vectors this time again. Now look, guys, the first vector is made with north because it says west of north. West of north, so I'm gonna choose north here, and then the angle is 30 degrees. What is d1 is equal to 75 kilometers. Now it says what? It says the second time it's 155 made with east of north. So this is east, this is north. Again, the angle is made with north, so this is 60. Okay, d2 is equal to 155 kilometers. Okay, now let's just analyze this into two components. This is going to be the first one, this is going to be the second one, the first one and the second one. This is dx1, dy1, this is dx2, and this is dy2. Okay, let's just calculate that, and as we have done that before. So dx1 is equal to what? Because the angle is made with the y component, so dx1 is going to be d1 multiplied by, d1 multiplied by sine theta, careful, because the angle is made with the y component. So sine goes with the x component, cosine goes with the y component. So I have 75 multiplied by sine of 30. Okay, I'm gonna calculate this. So we have 75 multiplied by sine 30. We have 37, so 37.5 kilometers. Okay, what about dy1? This is equal to what? It is equal to d1 multiplied by cosine theta. It's cosine again because the angle is made with the y component. So we have 75 times cosine of 30. Let's calculate this. We have 75 multiplied by cosine of 30. Okay, let's calculate this. We have 64.9. I'm gonna just call it 65 kilometers. So this is dy1, we found dyx2, dx1, sorry. So let's go to the second vector. So dx1, guys, again is equal to what? It is equal to d1 multiplied by d2, sorry, dx2 is equal to d2 multiplied by sine theta. Why d2? Why sine theta, guys? Because the angle again is made with the y component. Okay, so dx2 is equal to what? It is equal to 155 times sine of what? Of 60. Okay, so 155 multiplied by sine 60. Okay, we have what? We have 134.2 kilometers. That is my dx2. dy2, guys, is equal to what? It is equal to d2 multiplied by cosine theta. Okay, now this is going to be what? This is going to be 155 multiplied by cosine 60. Okay, so let's put that here. So 155 times cosine of 60. The result is what? Is 77.5 kilometers. Okay, guys, now let's find the total dx total and dy total. Let me use a different color. Now dx total is equal to what? T, of course, is equal to dx1 labar away, it's going to the left or it's going to the east. Kawata, don't forget to put negative. Negative 37.5. Please don't forget the directions. You can add them later, it's totally fine, or you can just add them with the angle. It doesn't make any change. Okay, so don't forget that the dx1 is going to the left. Okay, so it's going to be negative 37.5. okay, plus my dx2 is equal to what? It is equal to 134.2. okay, let's calculate this. Negative 37.5 plus 134.2. We have 96.7 kilometers. That is my dx total. So dy total is equal to what? It is equal to 65. Let's take a look at the angle, the direction. It's up, so it's positive. Okay, now 65 kilometers plus dy2, which is equal to 77.5. It's also going up, so plus 77.5. Let's add them together. 65 plus 77.5. We have 100. Let's write it here. So 142.5 kilometers. Now, guys, let's find the total displacement or the resultant vector. So the resultant is going to be what? Is going to be dx total, of course, squared plus dy total squared. Okay, this is going to be what? This is going to be dx total is equal to 96.7 squared plus 142.5 squared. Okay, let's calculate this. 96.5.7 squared plus 142.5 squared. Okay, this is equal to what? The resultant or the total displacement is equal to 172.2 kilometers. Okay, now, guys, you can calculate the angle also, but in the question it doesn't talk about any angles. Okay, question 1, it says identify a convenient coordinate system for analyzing each of the following situations. You have x and y component and you have a coordinate system. Just try to do them. Okay, it's not that difficult. So a dog walking along a sidewalk, you have x-axis, okay, and y-axis. Just to try to draw it. An acrobat walking along a high wire, same thing, you have x-axis and you have y-axis. Just try to draw it. A submarine submerging at an angle of 30 degrees to the horizontal. Okay, again the same thing, make an angle with the horizontal. Okay, means with the x-axis, and then draw an angle of 30 with the x-axis, and you have y-axis too. Okay, it's not that big a deal. Okay, now find the magnitude and direction of the resultant velocity for the following perpendicular. It says what, guys? It says perpendicular vectors. Okay, a fish swimming 30 meters per second. So it says a fish swimming. We have a fish swimming at 3.3 meter per second. So we have Vx, which is equal to 3 meter per second. Vx relative to the water across a river that moves at 5 meter per second. Vy is equal to 5 meter per second. Okay, guys, remember, if you have two vectors that are perpendicular, what do you mean by perpendicular? Okay, so this is Vx, okay, and this is Vy. What am I going to do with them? This is going to be the resultant vector, okay, or you can name it any way you want, but this is going to be the resultant vector. How can I do this? Remember, we said that we cannot add them directly, so we have to use what? We have to use the Pythagorean theorem. Be careful. So the resultant vector is going to be what is going to be Vx squared plus Vy squared. Okay, so this is going to be what? Square root of 3 squared plus 5 squared. Let's find that. So we have 3 squared plus 5 squared. We have square root of 34. So this is going to be 5.8 meter per second. Okay, this is the result. This one, guys, again, we have, I'm going to do this directly. So the resultant is going to be what? This is Vx, and this is Vy. This is going to be what? Vx1 squared plus 6 squared. So just try to calculate it, and you're going to find the result. Okay, you're going to find the result. So we have square root of what? Square root of 1 squared, just add this, square root of 1 squared plus 6 squared. Okay, we have 6.08, so we have 6.08 meter per second. Okay, this is the resultant vector. Okay, now we have question 3. Question 3, it says what? Question 3, it says find the component along the directions noted in parentheses. Okay, so we need to find x and y. Okay, this is a car displaced 45 north of east by 10 kilometers north and east. Okay, so it says a car, we have this, we have north, east. Okay, so displaced by 45 north of east. The angle is going to be made with the east because the second direction that is mentioned is east. Okay, then we have what? We have d, which is equal to 10 kilometer. Okay, it's very easy. I'm recommending you do this yourself. We have dx and we have dy. Just find them, that's it. Dx is equal to cosine, because the angle is made with the over the x-axis, so it's going to be cosine multiplied by d, and then dy is equal to what? Is equal to d multiplied by sine theta. Just try to do this yourself, please. Why do non-perpendicular vectors need to be resolved into components before you can add the vectors together? Because, guys, Pythagorean theorem, okay, or when we have an angle, we should analyze it into two components. But when we have fixed vectors, we can only use Pythagorean theorem. Okay, that is why non-perpendicular angles should be analyzed into two components. Okay, but for fixed angles, okay, like for example, you have two parallel vectors or you have two perpendicular vectors, you can just simply add them together or use the Pythagorean theorem. I think we are done with this section. Yeah, this was section review. And before I go, I just want to apologize for the delayment of the videos. I worked really hard to edit the videos and make them as helpful as possible for you. Sometimes they get delayed, but I have decided that I'm going to finish the curriculum, so I'm going to be with you all the year. Okay, so don't worry about, please, when the videos are getting delayed sometime. Okay, I'm trying as hard as possible to be ahead of you. Okay, so maybe at this moment you are in chapter 1. I'm already in chapter 2, so I'm going to apply videos before you reach the content or the chapter that I am in right now. Okay, so in the next lesson we're going to be explaining projectile motion. Okay, see you in the next video.